today we have built this ground station. The ground station here. So this ground station has two tasks to do. First is the measure the rocket thrust, rocket motor thrust, so we can easily analyze our new rocket motors we have built in future. And second task is to receive all the telemetry data coming from the rocket flight computer. So why we need the ground station to do two tasks? So it is cost effective, and that can do both the tasks to measure rocket thrust and receive rocket telemetry on the ground. So this cannot do both the tasks at the same time, because if we are measuring the rocket motor, we cannot launch rocket, obviously. If we are standing near the rocket motor test stand and due to some reason rocket motor explodes, so that can harm us. So we are collecting data wirelessly from the distance using LoRa module. Let me show you the module. So here is the module. This is module ESP32. This is LoRa module, and this is HX711 module, and this is LoRa antenna. And for weight measurement, we have used the I2C display over here, and this is a load cell connected to HX711 module, because we are using HX711 because signals coming from the load cell is very weak, very weak. So we are amplifying it via HX711 and inserting the signals into ESP32, and ESP32 will send signals wirelessly to the LoRa module, and we will receive at the other side of the LoRa module on our PC. So HX711 will send data to ESP32, and ESP32 will be doing some calculations, because we can't measure the weight by sensor raw data. We have to do calculations in the code. So that calculation will happen in ESP32. Then weight data will be transmitted to our other end of the LoRa module, and we will see all the thrust data or flight computer data in our laptop. LoRa module works on SPI communication, so it is used MISO, MOSI, SCK, and chip select and DIO 0. Now let's hop on to the building of the actual ground station. we are in now Arduino IDE. So we first include all the libraries. This is for include wire.h is for I2C protocol. Then we have liquid crystal I2C library and HX711 amplifier library. We are defining the pins over here, and we are defining some objects, and this is a calibration factor. We cannot use the HX711 with load cell directly, because we have to first calibrate it, and we have to change this value according to this is a calibration factor to calibrate our weight cell. And this is and now in void setup we are beginning the serial monitor at the 115200 baud rate. This is pin modes of LED and LCD setup and HX711 setup. We are introducing a delay of 1.5 seconds, and in loop, as I told that I like the airplane style blink, so this is code for that. And we are reading the values from the load cell, and we are here removing negative noise and printing the value. Now in this line we are printing the load cell values on the serial monitor, and after that we are printing the values of load cell on the LED display. And the whole process gap is around 50 milliseconds. You can change according to, if you increase that value, the load cell will update it accordingly. If you face any errors while installing the library, please check out the folder directory where your Arduino libraries are stored. So first we will go to documents, then here are Arduino and libraries, and if there is a same folder name, like in my case I had the liquid crystal I2C folder name, so I have to delete it and then again installing this library. So installed successfully. Now let's compile the sketch. So I have again modified the code, and we are getting the values. And one thing I added, because I like, if you can see the airplane lights that blink like this, I added into the code the blink, and weight is here. If I stay in the gauge, you can see the weight is changing. So it's cool, but if you want, you can add. It's your own opinion. I like the LED blink cool, so I added that. So now, as you can see, I have connected the load cell on the rocket motor test stand. This you don't have to make it that much big, but I have made this big because I want to also test the big rocket motors in the future. So it will give a much greater surface area. So let's connect this module temporarily. Now let's make it. As you can see, this hammer weighs around 200 grams because it is a light hammer, but it's light but very strong. Thank you everyone for watching the video, and support us on the Instagram and YouTube. Please do subscribe and click the bell icon so you never miss any updates from this channel. And thank you everyone for your love and support.